Hi, this is Yannick Inkicic, and this is my presentation, my final presentation for Fall 2018 Educational Technology of my development project. So I developed a real-time pixel-based cognitive assistant. Essentially, a cognitive assistant is something that supports us and enhances our capabilities in solving a wide variety of complex tasks. You might be familiar with obviously recent work in the personal assistant space. So you've got Apple's Siri, Microsoft's Cortana, Google's Assistant, etc. But all of these are mostly what I would call conversational assistants, in that they're reactive. They wait for us to ask them something and then help us. And obviously, for the most part, the goal there is to be a almost replacement for an inferior input device on mobile devices. So it's challenging to type on a small keyboard, much more difficult than using a mouse and keyboard on a full computer. But not much work has gone into creating an assistant that helps us accomplish our tasks, our goals, on a desktop or laptop device, on a full computing device. So that's what I wanted to accomplish here. But also, I didn't want it to be reactive. I wanted to proactively identify what's happening on screen and react in an appropriate manner, in a context-aware manner. So the way I approached this problem was by creating this real-time pixel-based assistant that is able to watch my screen, see what I see on screen, and react in an appropriate manner. So this project that I developed is at a high level, has a meta algorithm that is able to just constantly watch my screen and identify what's happening. And then it has these submodules that are domain specific that essentially are able to solve specific problems or tasks and help me out when appropriate. So I'm going to just demonstrate a couple of the ones that I developed here. One of them is a object detection module. So say I'm watching a webcam or a surveillance stream or something, and I want to identify whether there are people and there are cars. Maybe I'm counting traffic, that sort of thing. So I'm just going to launch that now, show you how that works. So here on the left, you've got what I'm seeing, and here on the right is what the algorithm, what the computer is seeing. So you can see that if I mouse over any of these images, it does a pretty good job at identifying the people in the image. These are people right here. If we search for something else, it'll do a pretty good job of identifying that these are motorcycles. This is a motorcycle and a person on it. Pretty cool. Similarly, if I launch a video, it should do pretty well. Here you can see it's identifying that these are people in this shot, and it's doing it live. It's streaming. No problems there. You can see even has a car in the background, has the people all identified. Wonderful. It's got any number of applications between surveillance or even accessibility. Somebody that is vision impaired could perhaps use this combined with some sort of text-to-speech and image labeling, more specifically, to be more aware of what's happening on screen just by sort of defining what is currently seen. Any number of applications. So I'm going to close this out for a second. And I want to demonstrate another module in the interest of time. This one is the game playing module. So in this case, I have the game 2048, and I have an algorithm that when it identifies that 2048 is launched, it essentially is able to play it. So here, you'll see it automatically playing it. I'm not doing anything now. This is the game playing itself. Sorry, the algorithm playing the game itself. And right now it's being run in fully automatic mode. So it's just I'm able to completely offload the cognitive load of trying to solve this problem and go do something entirely different, such as this presentation. So this game here is just a stand-in for any cognitively intensive task that I might have to do, whether it's working or trading stocks or whatever. The idea is that it's able to just look at my screen and figure out how it can help me have an easier time doing whatever I'm doing. So in this case, an alternative would be to launch this in hint mode or assistant mode, where I don't necessarily want it to solve the problem for me, but I want to learn. But I want to learn how to do this well or optimally. So on the right here, you can actually see it's streaming what the current representation internally is of the board and what the optimal next move is to maximize the score. So say we're playing this in a much slower pace of a human, and I wanted to figure out, maybe I get stuck and I don't know what the next move is. This would be able to provide a hint or a suggestion, like, hey, maybe you should try this move. This is the best next move. And essentially instruct me, teach me over time how to play. I'm going to pause this now. And then one final module that I built was this, essentially a way for the algorithm to redisplay things, such as the hints of how to accomplish a task back on screen. So this is relatively challenging, but one method creates this sort of overlay that just shows itself over everything else. So you can see here, I've got this EdTech on-screen text test, and regardless of what I have, it always shows up on top. So I can have any application running, and it's able to both see the pixels on the screen and display this overlay to provide me with hints or messages. I can also draw shapes, etc. I'm going to pause this now. So as you might be able to see here, I developed this project in Python 3.6. I used MobileNet SSD model for the object detection, but any model can be used very easily. If you want, more accuracy in detection. The whole point of this is more about the meta algorithm, the system that at a large scale is just able to watch the pixels at high performance. I'm running this on Windows, by the way, Windows 10 specifically, just because I want this to be maximally user accessible. So, over somewhere around 90% of all installed operating systems are Windows, so that was my target there. And then Python just supports rapid development. So the purpose there is to be able to create these modules in a prototype fashion really quickly. I'm very happy overall with the work that I've done on this project and what I've accomplished. It's pretty much met my goals. Obviously, 100 hours of work is not adequate to build something extremely complicated. So these are very much proof of concept type modules and applications that I've added here. But the whole point of the design is that it's extremely modular, and you can add additional domain-specific modules to this in an extensible fashion. Anybody can build one and add it to this very easily. So any task that you do that's repetitive or that you can algorithmically encapsulate or define, you should be able to fairly easily write up some code and import it here. And you don't need to hook into an existing API for a program. You don't need to look at memory addresses. You simply look at the screen the way we do and tell the program, like, hey, if you see this, then do this, that sort of thing, or solve the problem in whatever way is appropriate, defined by the developer. So very happy with this development project. I intend to continue working on it on my own. I think this is a great first step, but there's just so many applications that it could be used for, just between automating various things, or education, or accessibility, or supporting rapid prototyping in industry and enterprise. So I think it's a cool, novel idea in the sense that I haven't seen anybody take these various ideas together and put them into one complete package, and also a very easy one to work with. So I think it shows promise, and it shows an opportunity for further work as well. Thank you for listening.